So we're going for a Pearson product moment correlation coefficient question here. And Laxmi wishes to test whether there is a linear correlation between the mass and height of adult males. State with a reason whether Laxmi should use a one-tail or a two-tail test. So you've got to say with reason. You can't just say one-tail or two-tail. I think it's obvious to assume that actually mass and height are positively correlated. So therefore you'd go for a one-tail, one-tail, because, I can't even write because anymore, there's an assumption, that's what you'd write, something like this, I can't even write, assumption of a positive correlation between mass and height, or something to that. You'd say, you'd assume, you'd expect that the taller you are, the greater your mass, and you'd expect it to be positively correlated. So you go for something along that line. It then says Laxmi chooses a random sample of 40, so here's a sample of 40 adult males and calculates the PMCC, and she finds it's R equals 0.2705. Use the table below to carry out a test at the 5% significance level. Now these questions, they're worth 5 marks, but really I think they're brilliant ones to get. So if you get this, you're really in, quid's in. Watch what you do. You make the natural assumption, the null hypothesis is always that it's going to equal to 0. That your PMCC is always going to be no correlation. So there's always an assumption that there's no correlation. And what you're going to say is, well, you think in this particular case it's one tail, so you think it's going to be greater than, I can't even write 1, you think it's going to be greater than 0. And then all one needs to do is say, well, they've said it's a 5% significance level, it's one tail, so we're looking at the 5%, one tail, and we looked at 40. So there we go. That's the number we're looking at. And we look at the data they give us, it's there. So what we say is that as 0.2705 is greater than 0.2638, we then reject, because it's in the critical region therefore, we reject the null hypothesis. And again, there is significant evidence, or sufficient evidence, one should say, you could say significant, I suppose, sufficient evidence at the 5% level of significance to suggest, now this is really important, you can write all that, but you've got to then contextualize it, and then you say suggest, let's look at this one here, what are they asking you? Suggest that there is a positive linear correlation between the mass and height of adult males. So you could basically copy out that line afterwards, and that'll be really key. And it's 5 marks, it's really quite straightforward. Okay, let's go for the 4th question in this and see what that asks us to do. So here we go. Let's see, this says, here we are. There we go. So this says the times taken by employees to complete a task are normally, this is a normal distribution, so it's a normal distribution. Standard deviation, so we don't know the mu yet, but it's 2.6 standard deviation, so I'm putting the square there. Again, remember, if it says standard deviation, we put the variance in there, that's key to all, so that's our X bar. A manager claims that the mean time is 15.5, so that's what he thinks, he says it's 15.5. But an employee suspects that the mean time is greater than this, so that indicates kind of like a one-tail direction we're going here, isn't it? He intends to carry out a hypothesis test at the 5% significance level to test his claim. He records the times taken by a random sample. So we've got the distribution of the sample means going on here. So that is that one there. And what we're going to say, well, the assumption is it's going to be 15.5. That's the empirical one, that's the standard, and we think it's better than that. But because it's a sample, we have to divide it by those 12. And so that is now our parameter base from which we can work on. Now it says it's find a critical region, 5%, and we know it's one tail. So we know it's 5%, one tail. And there are different ways to do this. So we've got, if I draw the hypothesis test like this, that's what the standard was, and we're saying, well, actually it's here, so we want to find the critical value there. And there's lots of ways of doing this, and the way I'm going to do it is say, well, I want the value such that this area here occupies 5% of the total region. That's what I want to do. So how do I do that? Well, let's put CV equals the mean, then divided by, we're going to put that into here now, and just see what comes out. We know we want it to be, now 5%, one tail, if you check on your calculators, or they should give you this, the z-score value of 1.645. So what you do, and I've done this one before, is you times that by the denominator and then add 15.5, and you should come to 16.7. So therefore, and you need to write this, the critical region, so critical region, always answer the question, is such where the standard mean is going to be above 16.7. And that gets you your 3 marks. Then it says the total mass, the total of the times taken by 12 employees was 202.1. Carry out a test. So carry out a test. We know that the null hypothesis is always going to be the standard, that it's 15.5. And we're going to also say that the alternative hypothesis is that it's greater than 15.5. You write one tail, 5% levels of significance, and notice the repetitive nature of this, and it is always going to be the same repetitive nature. And we know that the thing we're testing is x bar being 16.84. How did I get that? Well, I know it's going to be 202.1 shared by those 12, and that gets you your 16.84. So that's how I get my 16.84. I know now that the region here, the actual valued region is 16.7. This one lies in here, so therefore it's in the critical region. So what am I going to do? Well, I'm going to write reject null hypothesis, and then I'm going to say there is significant evidence at the 5% level to suggest the mean time for tasks is greater than 15.1. And you do need to scribble that out. You need to write it all out as well. And of course, you're going to use the words that they put in here, because that really makes sense as well, and that really helps. And there's 8 points for you. I hope this has helped.